Now, this is a confidence interval problem. It's going to be found on test 3. It's questions 4 and 5. So make sure you can do it.
So there's 2 different questions on it related to this?
Yeah. So, recent survey, 845 people indicate that 447 of them drink soda at least one time a day, or excuse me, at least one time a week. Use this to construct a 90% confidence interval for the true proportion of people who drink soda at least once a week. So, first step is to draw a picture where you're going to have the inside part is 0.90. Now, if 90% is on the inside, what percent's on the outside? That'd be 10%, right? Which means each little piece turns out to be 0.05. Okay? Let me pause this. I'll be right back. All right, so if you go to the z-score chart, you're looking for 0.05 on the inside part of the chart. Now, you're looking for 0.05 on the inside. Well, there's 0.005. You're not looking for 0.005. You're looking for 0.05. So there's 0.0505. There's 0.0495. 05 is right in the middle. Notice there's a star there. That star tells you to look down and to the left. Okay?
I have a question.
Yes.
Why are you looking for 0.05?
Because 90% is in the middle. I apologize.
Oh, no, I understand.
Yeah, just let me finish it because people are watching it at home. The question was, why am I looking up 0.05 as opposed to something else? The answer is 90% is on the middle, so that's 10% left over, right? And if 10% is left over, half of that is 5% on both sides. Okay? So 95% is, or 90% has 5% left over on each edge. Okay? So looking up 0.05, you get 1.645. So the z-score for that then is 1.645 and negative 1.645. Okay. Now, part B, you got to know the formula. The formula, for those of you that don't know, is right here. Right here. So what I'm going to do is cheat. And just go like this. That way no one has to complain about how crappy my handwriting is. There, that goes for part B. Perfect. That's the best I've written all semester. Okay. Now, part C. Part C is where you're going to do the work. So let's figure out what P hat is. So P hat is equal to X over N. So in our case, it's 447 divided by 845, right? All right, 447 divided by 845. So now what is that? Well, let's go to our calculator. And we'll say 447 divided by 845 is 0.53. You could use 0.529 if you want to. So 0.53. So now we're going to go 0.53. Uh-oh. 0.53 minus, what's z alpha over 2? 1.645. Just plug in this number into the z formula. Times the square root of 0.53 times what?
Q, 0.47.
Times Q, which is 0.47. It's the opposite. Over 845 is less than P, which is less than 0.53 plus 1.645 times square root of 0.53 times 0.47 over 845. Now again, just to type that in, show everybody how to do that. I'm going to type into this left side first. Let me clear it. Let me get rid of this. Let's go ahead and do it now. 0.53 minus 1.645 square root, and this is where you got to be real careful. I don't want you using parentheses to represent multiplication, because a lot of people will do something like that, and that ends up closing the square root too early. So don't use parentheses to represent multiplication. Use the actual division bar, or the multiplication symbol, times 0.47 divided by 845. Okay. Now that's the left-hand side. The left-hand side is 0.502. The left-hand side is 0.502. Okay. What's the right-hand side? You got to do the same formula, but change the minus sign to a plus sign, right? So hit second, enter. Change the minus sign to a plus sign. 0.558. Now I'll go ahead and save that. Okay. All right, now how do I interpret? Again, we're going to be using this as our interpretation template. If we continue to take samples, you know what? Let me pause. Come on, you jackass.
You didn't pause.
All right. Any of you parents join us at home? I'm really a nice guy. All right. So, if we continue to take samples of size what? 845. That's your sample size. Your sample size is 845. So if we continue to take samples of size 845, we expect what percentage? 90% of the sample. What are we dealing with here? Proportions. To be between 0.502 and 0.558. Okay? And that's probably way better than any writing I would be able to do for you. E. Okay? E. What are your assumptions? Since n times p hat and n times q hat greater than or equal to 5, the sample proportion is normally distributed. I use ND to represent Notre Dame or normally distributed, depending on the context. In this case, it's normally distributed. Okay? All right, everybody straight on that. Now, since I did cuss, and some of you are going to hear it twice, offering up a peace offering. Remember, Amber, we were talking about how do you know if you have it right? Remember that? Well, I will say for the record that you are officially a nerd if you have a calculator like this in front of you, not right now, just in general, and you know what every button on that thing does. See, there's got to be at least one button that when you look at it, you go like this, I don't know what that thing does. Then you're not a nerd. But if you know what every button does, then yeah, you're a nerd. Now, some of you have played with the stat button before, maybe because you're in stats class and you think maybe you should press that and see what it does. And you know that's where we found the average and standard deviation. Remember, that was a really cool thing? Let's go backwards to test. Or you can just skip forward twice to test. But anyway, get to test. And we're going to scroll down to option A. Option A is one proportion Z interval. Now here's what you're going to do. You're going to press enter. It's going to ask you for your X. What was your X in this case? Anybody remember?
447.
The X was 447. What was the N?
8.5.
And our confidence level was 90%. We're going to press enter.
So we did all this work by hand, why? Yeah.
Now, what did we get? Let me just check it. We can check it here. I don't remember. We were pretty close. Okay. I don't know where the button is to close it. That is the way you check it, Amber.
No, how about that's just the way?
Oh, how about that's just you do it that way from now on and you don't do the rest of it?
No.
No. Yeah, good idea.